You are welcome to the subject of hydraulics. And today's lecture is on groundwater. And today we are starting first lecture on groundwater. Now, under today's lecture, we are going to consider cover the following topics: one, occurrence of groundwater. Second one, other forms of underground water. Third one, terminology used. And fourth, the basic principles of groundwater. Those are the topics that we will cover under this first lecture. Occurrence of water. Consider the ground surface and the bedrock here. The rain, first we are starting with the rainfall. The rainfall falls on the ground as surface precipitation. It is called precipitation. Out of precipitation, part of precipitation come down as percolation or percolate down, and water get collected here, and this forms the groundwater. That is how groundwater is occurring inside the ground on the bedrock or the impervious surface. This is groundwater. So the soil bearing groundwater strata, these are soil bearing the groundwater strata, and that soil bearing groundwater strata are known as, this strata is known as aquifer. Special name given to the water bearing strata underground is aquifer, one term that we are going to study today. Now, in addition to this groundwater, there are different other types of water present underground. We deal with them one by one. Sometimes you can see, when you take a cross section of the earth, you can see the mass of soil suspended inside the ground like this. Under capillary action and again by surface tension effects, some mass of water remains like this without going down. Just in suspension. This kind of water is known as Weather's water. Sometimes a similar mass of water exists spontaneously due to thunders. Due to thunders, hydrogen and oxygen combine together to form molecules of water. They combine to form some water just like this. That also exists as the mass of water suspended inside the ground like this. That what is known as juvenile water. In addition, there can be another way of getting water. There can be sometimes a rock layer, a cup-shaped rock layer occurs inside the ground, and the cup-shaped structure can retain some water after rainfall, like that. So it can retain some water. So that water gets collected there. That is known as perched water. Similarly, there can be a rock layer like this, or cup shape here, that may get some water from rainfall water or flowing water, and after some time the whole thing may get covered with a rock layer. After a long time, it may get covered with a rock layer again, so that the water inside is permanently hidden inside, concentrated or found inside between two rock layers. The water cannot come out. So right now, this water is known as connate water. So this kind of water is not groundwater. This water is weather water, juvenile water, perched water, or connate water. They are not groundwater. They are just masses of water existing underground, and someone may, after drilling a hole into that to get water, he may get water. Drilling a well, Into this he may get water, but that body is very limited. It's very small amount of water. Very soon that disappears. So this is not underground water. This is not groundwater. In other words, sorry, this is not groundwater. Now, dealing with this aquifer. Aquifer is water-bearing strata, and we can get on to another diagram now. Consider this diagram. In this diagram, this is the bedrock or impervious layer, bottom layer. Here, ground surface. On the ground surface, you have the plantation here, and there's another rock layer inside the ground like this, above the bottom rock layer. And by rainfall, water get into this, and water comes here. Some of the water go into all that water comes here like this and go into the aquifer like that. So they form the aquifer here. So if I indicate it, this is ground level. There can be situation like this. This is the bottom rock layer. This is the surface, ground surface. We get rainfall coming from the sky, falling on the ground as surface rainfall collection or precipitation, we call it. Some of the precipitated water trickling down like this, and the other part going as surface runoff, recharging the streams here, and some of them going down like that, again going to the streams like that, and some part coming down to recharge the aquifer. The percolates, forming the aquifer here. So water goes to the aquifer. So this is the aquifer inside. Now, if you look at this aquifer, you can see that it has a water table here. It has water table. There is a free water table here. But some of the water going into these impermeable, there is another impermeable layer. One impermeable layer. This is bedrock is also impermeable. So the water goes into the space between these two. It's not the space. The soil between these two. Water gets into that soil. So these also aquifer, but there's small difference. One difference is that this is a free water table from here to here. When you draw a line like this, from this line leftwards, this part has a free water table, but this part does not have a free water table. But when you dig a hole here, or make a hole here, sometimes water may come up like this, up to this level. So as a result of that, you can assume that this is a pressure level. So when you make a hole here, what is able to go to that level? So this is the pressure level of that water. And this pressure level is known as the piezometric table. That surface at that level without water, the imaginary surface, or in the imaginary surface, that imaginary surface is known as piezometric table that shows the pressure of this particular water. So as a result, now we have two types of aquifers. One with a free water table, other one without a free water table, but with a piezometric table. So therefore now these confined between two rock layers or two impermeable layers, we call it confined aquifer. And this part is called unconfined aquifer. So by this time you are learning these two types of aquifers, the confined aquifer, unconfined aquifer, piezometric table, water table. Because the water table and the free water table and the feasibility table, these two are given these names. These is also named as water table aquifer. This is known as piezometric table aquifer. It will be called as piezometric table aquifer. So you can see that there are two types of aquifers: confined aquifer and unconfined aquifer. Right. I'll erase this diagram. You can see that in this diagram you can clearly shown this is an impermeable layer, impermeable bedrock, the surface of the ground here. There's plantation here, then it shows the hydrological cycle, rainfall coming on the top, partly get down, percolate downwards, recharging the aquifer, and partly going over the surface and recharge the streams, rivers, etc. And when you dig a well, you can have a well like this here, like this you get water, and the plants get water from the ground, and it transpires upwards, and transpired water goes into the clouds. Clouds can travel this way, and when the cloud gets cooled down, the water globules become water globules. When the rate increases, it comes down and rainfall again. So this forms what is known as hydrological cycle. So we can see that now the groundwater is also one part of the hydrological cycle. It is no doubt that groundwater is a part of the hydrological cycle. Now we shall come to the principle of groundwater flow. We come to the basic principle of groundwater flow. You can consider an element of the aquifer like this first. This is part of the small element of the aquifer. In this, the blue color indicates the level of water. If it is horizontal, if the level of water is horizontal, it shows that there will be no flow in the element. There is no flow in the element. But if there is a flow in the element, this surface get a shape like this. Surface of water will get a shape like this. In other words, you can see that there is a gradient towards the direction of flow. The direction of flow is like this. It will take place like that. In that particular direction, there is a gradient of the liquid surface. Now, if we take a small element or a strip of this water, if you consider a small strip of the water prism, you can consider a small prism of a thin prism like this. You can see that there is a small triangle here that shows there is a certain amount of gradient at a particular point. Actually, there is a gradient here for the whole surface. When you consider one point, there will be a gradient. That gradient is called the hydraulic gradient. Suppose this is of height h, this will be of height delta h. Consider this small distance to be delta x. The gradient here is delta h, delta x. And you can see that now it's a negative gradient. If you consider the direction of flow, the direction of flow is like this. This is the velocity is this direction, and that velocity is is connected with this gradient, but this is a negative gradient. And whenever there is velocity, there will be a negative gradient occurring. So that now you can see that now this is proportional to the amount of the gradient. You can put it in the equation as V is proportional to the hydraulic gradient, like that. Because it's a negative gradient, you put it negative. Now we can remove this proportional sign with the equine sign, putting a constant k, delta h, delta x, will be, and you can replace this symbol. You can replace this delta h, delta x with the symbol I, We rewrite it again as K is equal to V is equal to Ki, where V is the velocity of flow, I is the hydro gradient, is another constant here. We call this part the Darcy's law. You can't stop with Darcy's law because you may know that there is Darcy's law for pipe friction, so therefore you have to tell the whole thing together here. Darcy's law for groundwater flow. But you can see that is a negative gradient, it exists negative here, the negative sign exists here, negative sign exists here. We are putting the negative sign because this is a negative gradient. To make it positive, we put an additional negative sign here. That's what we do in the Darcy's law. So already this negative might be there. But for normal calculations, to find the velocity, you can put K and I separately and find the value. But in further calculation, if you go deep calculation, you have to always go with this negative sign always. V is equal to minus Ki. That is the Darcy's law. In this, we have the three terms now. V is the velocity of flow to the porous media. K is the property of soil known as permeability. This is the property of soil known as permeability. And I is the hydro gradient. Now we talk about permeability. Permeability. The English meaning, normal English meaning of permeability, as you know, it is the ease with which a liquid flows through a porous media. That is the normal English meaning, but in this scientific definition, is you can see that when you take this this to one side and put the other to the other side, it will be velocity divided by I. It shows that it is the velocity per unit hydro gradient. So the permeability is defined as the velocity per unit hydro gradient. Velocity of flow per unit hydro gradient. That is K is equal to V divided by I. That is the definition for that. Now coming to the units of permeability. The velocity will have the units of velocity. Basically, it is normally taken in meters per day because the velocity of flow to porous media is very little, so then we can put it in meters per day. And I is measured as delta H divided by delta X. Both are measured in meters. These hydro water measured in meters. This term measured also in meters. So therefore, meters cancel out, and there will be no units for the hydro gradient. In which case, the permeability will have the same velocity units. It will have the same velocity units. That's all about